All right. Good afternoon, everyone. I'm Babak. Thank you, Francois, for the introduction, and thank you for organizing this meeting. I think the topic is very timely, super important. We have great people on this panel, actually, and hopefully this would be entertaining. We got about 50 minutes or so of time with pretty amazing people. So the three people that we have here on the panel, the panel is called "What Does the Industry Need to Succeed with AI?" I didn't come up with the title. I was given it, so I'm just kind of reading it from my phone. But we'll make do. So the people that we have on the panel are actually pretty remarkable people, and they represent two of the three hyperscalers. We don't have an Amazon person here, but we have two of the three hyperscalers on this panel. So here's your opportunity to ask like really interesting, good questions from them. And also Boeing, which is an amazing, it flies even above the clouds. So this is a great company. Very proud actually to have it in our region. So the people that we have on the panel, we have Ajay Kamar. From Microsoft, who's directing a pretty interesting lab. She's going to tell you about it, actually, what she's up to. We got Vishwa Udhanwalkar from Boeing, who's in charge of generative AI at Boeing. It's my favorite topic, or subset of AI. And then we have our very own Shwetak Patel, known to probably all of you already at UW, a great entrepreneur, and also at Google at the same time now. So we're gonna start the panel by asking you guys, if you don't mind, and you can take as much time as you like, to tell the audience here to kind of do some table setting here, what your company is up to. So maybe if you could broadly talk about this, and I know it's very, you can spend probably 5 days talking about what Microsoft is up to, for example, in AI or any of these companies, but maybe you could sort of compress it to a few minutes, less than 10 minutes. But what your company is up to in AI, that's new. So maybe also focusing on the stuff that's more recent. But also after that, just telling the audience what is it that you work on and what is it that you're excited about. So Ajay, maybe I will start with you and sort of go this way. So what is Microsoft has been up to in the recent few weeks besides changing the board in OpenAI? What are you working on that you're excited about?
Yeah. Many people know what Microsoft is up to. Actually, what Microsoft does is very simple to explain. We are a platform company and a productivity company, and those are the two things Microsoft does. So the first thing is Microsoft has this partnership with OpenAI and also trains models in-house and then hosts models from everybody and builds a platform for any business to build AI systems with. So that's the first line of business, which is being a platform company. And the second one is, as a productivity company, completely reinventing what productivity means, given that we have generative AI and these chatbots. And it is actually a pretty interesting transformation I see, just like being in research and looking into the company, that the moment people got their hands into GPT-4, which was, for us, actually, it was before ChatGPT came out. So we got to see GPT-4, a version of GPT-4, then ChatGPT, then GPT-4. It was clear that this meant none of the products we use today are going to be valid in a number of years. And it's a pretty tough realization to say that, like, if you're head of Outlook or whatever product, your product is dead. And then you try to imagine what that product is going to become so that you can still be relevant in it. And the strategy there is really the co-pilots, building these agents, going from models to agents, that agents can be the new interface to computing for people. So those are the two things Microsoft has been up to. And of course, Microsoft has this partnership with OpenAI, and that made things kind of tricky for MSR. Right? I sit in Microsoft Research. And at the time of the OpenAI partnership getting really big, of course, like I was a deputy director in the Redmond lab, and we got to see many of the challenges you are talking about. Our researchers going through the same challenges and still going through them. Because getting compute is still super hard. I don't know how it is at Boeing or Google, but it's not something that is readily available for anybody for them to do whatever they want to do. Because as these products go out, there's a question about how do you support the inference of all of those products using ChatGPT or GPT-4 or any of these models. So we are still dealing with what compute really means and how to organize ourselves for bigger impact. And that's why I just 3 weeks ago started a new research lab inside Microsoft Research called AI Frontiers. AI Frontiers is our effort to organize ourselves in a mission-focused way so that we can get together to do really clear, impactful things for the company. And that way we can get more resources. And that's one of the things I really resonated with listening to the previous panel, because this is not about giving everybody something at the end of the day. That's not how this AI research is going. It is really about creating a strategy and a mission to pull together the right people in complementary ways to be able to achieve goals. And through doing that, opening new frontiers in research. Because one of the things I really believe in is that, of course, transformers is not going to be the end thing. But whatever path is towards the next thing is going to go through what we are passing through today. And having that hands-on experience in terms of building models, seeing where they work and where they don't work is the key to unlocking new frontiers in AI. So we are trying to create that hands-on experience for all of our researchers, define clear milestones and missions so that we can organize ourselves. And this is what this new effort is about. And we, of course, collaborate very closely with the traditional MSR in doing this. But we are realizing that it's going to be really important to have more coordinated efforts to make progress in this space. So I'll stop there.
Good afternoon. My name is Vishwavardhan Wadekar, Boeing company, been there about 15 years, and before that with companies like Honeywell and others for several years. So feel a little bit like fish out of water when talking in the middle of tech companies, like a Democrat arrived in a Republican convention kind of thing. But the thing is, we've been alive for 108 years. And that means clearly, first of all, we are not a digital native company. And yet, we have sensed tremendous opportunity and benefited from it. It's just sometimes a little different from what the rest of the retail world gets. And one reflection that I've had over the last few months is, in the past, innovations would start somewhere typically like in a defense lab, then get to industry, then get to retail. That flow has completely gotten disrupted. Innovation happens somewhere and gets thrown to the retail world, then comes back to industry and military. Think drones, think additive manufacturing, think about the last 8 to 10 years, and the flow of innovation has changed, which is what exactly you saw also with generative AI. In terms of the future of AI at Boeing, I think it's important to spend 2 minutes on the future of aerospace. We define it in 4 words. The future of aerospace is sustainable, digital, producible, and autonomous. I see AI in all 4 of these, not necessarily generative AI, but sort of what became now very quickly old-fashioned AI, where you do actual, thinking in the wild, detect and avoid algorithms, image processing, computing at the edge, all of that, what was yesterday new has become old now. There's a lot of application of that still in our world, a lot. So when it comes to the future of AI within Boeing, we have that entire space of autonomous, and we are now looking at ways in which we can train foundation models with Boeing data, trying out different types of chunking, trying out different types of fine-tuning, just like Ali showed on his charts, trying out different RAG models, and looking at ways to actually unlock all of the knowledge that is resident within our data. So that is new and novel for us. I am a part of the engineering function within Boeing, and that's where a lot of this thinking and knowledge creation happens. So we are super excited about this new trajectory. We have similar compute challenges like have been spoken, But we're taking a slightly different approach there. For us, we don't have to make everything ourselves. Our objective is to figure out how to apply it sooner, faster, better, to make lives better and more efficient, so that our workers can, move up in terms of the value of work that they do. So for us, it's not that much about, okay, the neighbor made a 70 billion token model, we need to make 140 billion. That's not the race we are in. We are also extremely focused on intersection of certain disciplines, like this discipline with human factors. We have found again and again that innovation races ahead, and then someone says, we didn't think about human factors, and so we need to get that back. And in our industry, that is a very, very important part.
Great. I think a lot of you know what Google does. Google is an information company, but also a platform company. So today you probably saw Gemini was released, particularly Gemini Nano on mobile devices, and you have the cloud version. But what I do at Google is I also run a team, a health AI team, particularly focused on what can we do with the vast amounts of consumer health knowledge that you could get from phones and wearables, medical knowledge, but what can you do with AI? And so it's been an incredible journey crossing both the Allen School and Google, where a lot of the interesting work that my students have been doing in AI and health, I've been able to scale it through Google. And kind of going back and forth between these two worlds have been an amazing journey, because I've been able to kind of steer and influence Google to go down a path that they may not have gone down if a set of academics weren't able to influence them. So we do things on screening and diagnostics. Recently, we just published a paper where we showed that AI models, particularly LLMs, can do differential diagnosis. So what that means is that previous models have been able to pass medical board exams, Q&A questions. But what we did was we took 300 of the hardest New England Journal of Medicine case studies, and we created a model that could actually reason on case studies. And if you gave it a case study, it was able to unpack the case study, look at the patient history, look at demographic information, look at their particular symptoms, and actually diagnose it better, as well as, or if not better, than the expert attending that was on the case. And so this, you can just imagine what you can do with this. I mean, this democratizes healthcare. So a lot of the things that I do is take that work and look at how do we empower community health workers? How do we empower clinicians in rural communities where you can't get to the clinical encounter fast enough, or you might not have access to that? And so that's what my team at Google does. We look at how do we use the access to these data sets and these computational models, and look at health solutions. So my team cuts across many parts of Google. So this includes YouTube search, Pixel, Fitbit, and so it's more of a cross-functional, cross-cutting set of organizational efforts that we focus on, where we're trying to bring Google, at the end of the day, is an information company, as I said, and some of the most important piece of information is about one's health. And so we're trying to figure out how we can make that more available to many, many people.
Great, thank you for sharing. So yes, super well-known companies, obviously. So when you think about some of the challenges that you have right now in your work and things that are difficult to solve, so what are the opportunities that you see working between your companies and the University of Washington? Where are those intersections, and what would you like to see on the University of Washington side? And I guess put this very bluntly, what kind of offer can UW make to you that you would not be able to refuse? Say, okay, so you really need to do this with UW. So where are your needs? Where do you see the intersection? How would it work out? So maybe start this time from Shweta and come this way.
Yeah, I have the luxury of benefiting from both organizations, but I think one of the things that's because I have visibility in both industry and academia, and one of the things that's clear is that even Google, as a very large company with lots of resources, we just can't do everything. There's no way we can, at Google, match the breadth of the University of Washington. No way. There's no way we can ever match the breadth. If you look at everything that we're doing on life sciences, foundational models, if looking at policy, ethics, there's absolutely no way. So I think that's the key thing for us, is that we have to figure out how do we harness that breadth and get it exposed to not just Google, but a lot of the companies that we want to collaborate with. Because some of these concepts may be thought of in a lot of these teams, and I see this. I see somebody debating a particular maybe AI and ethics issue, And I'm just sitting there thinking to myself, there's an entire university right here that has thought about it more deeply. I need to figure out how to bring that to bear. So I think that's the thing that's really valuable, and how do we create this fluid interaction with industry so that we have the experts being able to engage with industry. So I think that's one. The other thing is that students are really excited about this space of AI because the pace of innovation is so amazing. But I think training students in ways that they can appreciate how can you scale some of these things, what are some of the industry challenges, what are some of the application areas that really can have a huge impact. So figuring out ways that we can, particularly we meaning industry on this, engage with students more deeply as well. Because we do a great job at UW, graduating students, they go off in industry and faculty positions, do a great job, but I think that co-mentorship can happen way earlier before we set them out to industry. So I think those are the two big areas, is I think there needs to be a lot more fluidity between the University of Washington and industry.
So, sorry, Shwetak, I want to actually push on this a little bit. So, what is the challenge that you have that you cannot solve at Google that you really need to come to UW to get it resolved?
I think, one concrete question are compelling applications, right? So I work in computing and health. Health is very broad, but even within that, there's just so many different areas. Just in the previous panel, we heard a pitch for Scribe, medical Scribe and summarization. I think those domain applications are really critical because I think that UW can really help us figure out what are the right domains to focus on and then put the energy towards that.
Mm-hmm.
Yeah.
Thank you. Vishwa.
A couple of things come to mind. I saw Professor Lazowska earlier here. Maybe he's left. Okay. Yeah. The thing is, we have done so much work with the University of Washington over the decades. It's not new for us. Professor Lazowska, Professor Steve Brunton, they helped us with a lot of data analytics teaching curriculum. That's live within the company now. We've done much work in deep technical computational fluid dynamics types of areas, so we know what types of use cases are actually suitable for this. We've also seen what type of partnership works. There are some that have to be co-located. So those projects worked out because university researchers and Boeing employees were co-located. So we've learned those lessons. But right now, specific to AI, a couple of things come to mind. Obviously, teaching and making it accessible to a wide variety of people of variety of backgrounds is very essential. When I say that, I have our employees in mind. They are anywhere between double PhD to trade school. And initial research has shown that, for example, generative AI has a much bigger multiplier on productivity, quality, speed if you are in the trade school category of capabilities. So you've got the Kruger-Dunning research, you've got all of that in that area, but how do you make it accessible to someone who doesn't know prompt engineering, who doesn't even know how to use agents, and so on? So since one of the charts talked about societal impact, we've got to be real and talk about it. How do you get a person from a trade school to do this? And how do we make it accessible? What's the societal angle here? The second one is good research. What I mean by that is during the pandemic, there were, at one point, at least 2,500 papers per day uploaded to archive servers. Something happened and people lost all patience for peer review. I see that happening again with generative AI. I go to archive servers every day to just check what the F is going on. And it is a feeding frenzy. And we need to get back a little bit to good research, which is peer-reviewed research. And I think that is something that we yearn for because we want to apply. We are in the application, someone said, making money side of the game. Sure. But we can do that if we know this research is really good. Today, I can sit up overnight and upload something to the archive servers tomorrow morning and people won't know what's going on. And third and last thing is convening like this. Universities provide the perfect neutral ground for convening. And a lot good can come out of that. So those are my three thoughts.
So, Vishwa, I want to actually, so it's really great points, and I totally resonate with your point about convening, by the way, because the university absolutely can be a neutral ground because these big behemoth companies are fighting each other for commercial reasons, but university could be the place that they can come together and not fight, and just like Switzerland, it's just like peace, and then we can discuss and learn from each other. So that's a really good point. And obviously, universities train everyone that works in these large companies. So that's mission critical for the companies to support the university. But I want to go back to your point about the papers going on archive, because we have academics here. They publish. Every paper that mostly they care about is published in a peer-reviewed journal. So what is the problem of actually people just putting their work on archive right away? So instead of waiting for 6 months for my paper to come out, tomorrow morning is available globally. Everyone can see it, and they can replicate my results. And if it's wrong, it's wrong. But if it's right, it's out immediately. So it accelerates basically the progression of research. So what's the downside you see in that?
The downside is that it has not been looked at critically. So if one were to just take it and start working off of that, you could be off by a huge margin.
So you think there's like wasted cycles and effort if the paper is wrong or like fundamentally incorrect? Mm-hmm.
Yeah. Or very subjective, or applicable to a very niche set of scenarios. And you want to broaden it, but you can't because it was done in a very niche sort of experiment.
Mm-hmm. So one more point before we go to Ajay. So in terms of convening, what can UW do actually that would be materially useful to Boeing? Like what kind of convening would you like to see the university do?
So we have some use cases that are shareable, which are generic engineering manufacturing type of use cases. We can bring those forward for discussion. I know that tech companies are always looking for opportunities for real life scenarios to try out their upcoming innovations on. I think that could be something we could consider. Great, thanks much. So, Ajay, it's your turn.
Yeah, I want to build on something both panelists said. This conversation is really about pace. It's really about speed. And the speed we are working on right now is disruptive. It is sometimes demotivating. And it is really important to think about what is the role of a university when everything is changing so fast and developments are now we are talking about in the matter of weeks, not months, not years anymore. And there, I think the universities have a big role to play to say, stop, let's think about things in deep ways. Because as industry, even inside a research organization at an industry, it is very difficult to resist the speed that things are flowing at you. And I feel that every day as like building this new research organization, how do we trade off the pressure to go fast, do the thing that is just around the horizon, versus balancing the ideas that are going to be coming afterwards and mattering so much than what we are going to be doing in the short term. So talking about like the modeling side first. It is very clear that what we are seeing today, scale with transformers, with more data, is not the end game. There is a lot of scientific proof that it is not it. We have been releasing small language models out there with the Phi family, with the Orca family, where you basically show that you can get the reasoning power with 1/10 of the size, which means size is not it. Like we are not going to get there only by scaling things. The question is, how do we actually get to those ideas? Maybe they are influenced from neuroscience. Maybe they are influenced from cognitive science. That interdisciplinary discussion is where a lot of it's going to happen. And let's admit it, Microsoft Research doesn't have that talent at scale like UW does. So we have to partner to kind of get to that next frontier of ideas. And my biggest worry as a director of a research lab in industry is that we are so focused on short term that we are going to be missing those ideas. It's perfectly fine if they come from UW. We love new ideas. We'll scale them with you. We'll try those out. So that's one. The second is also, like so my last 10 years has been about building responsible AI processes and infrastructures and tools inside Microsoft. I helped to build, how GPT-4s get into products and all of it. So what we are seeing is that the fact that you have a powerful model does not mean that those models are going to be doing the right thing when they get into products. It takes actually a lot of really complex machinery, new ideas, new techniques to make these models work in applications. So those ideas do not require the compute the same way the advances in modeling side does, but they matter so much. Maybe this is not something that the machine learning community is paying enough attention to, but if you look into GitHub, what developers are doing, they really, really care about these libraries that does the orchestration. One of the things we've been pushing a lot is multi-agent orchestration. How do we actually build multiple agents, get them work together, and that way we can push the frontiers of AI. Those ideas do not require resources. They require some creativity and connections. Because we all know that multi-agent systems, like people in this group, work really well together to kind of get new ideas. Third, responsible AI. Again, this is a critical area where we need some new thinking, especially with generative AI. The way we think about responsible AI needs to completely change. We are getting into these discussions about closed versus open. I have a lot of thoughts on it. I don't think that's what you invited me here today to discuss those, but happy to discuss.
We would love to hear it. You go for it. So, friendly crowd.
Yeah, so for us, I've done so much red teaming with these models that I know that if they are given to some adversarial scenarios, they can be very dangerous. And I can tell you that what you see in the systems today are not the full capabilities of these models either. So I personally have pushed for not open sourcing some of the models. I know this is not the popular idea here, without having the right protections and regulations, because I have firsthand seen the dangers that they can create with red teaming. I just want to put that perspective out there. At the same time, now being a director of a research lab where people need models to do the work, I also believe a lot in open sourcing. This is really a question of walking the line in the right way. So that's my quick answer to the question. Fourth, this is a transformational moment. The effects of these technologies in the world are going to be far beyond just the productivity scenarios. There are going to be major changes that affect the future of work, productivity, education, and I would really like to also get to some interdisciplinary discussion to discuss what these trends and improvements mean for different domains. And the last thing is I want to just touch on convening. If you go to Twitter and just listen to some of the AI people discuss AI developments, it is becoming a very poisonous debate right now, where people are dividing into camps, and each one is trying to prove that they have said the right thing 2 or 3 years ago. It really becomes, a lot of the conversations become about egos of individuals, and we are missing the big picture in those discussions. We really have to have balanced discussions about where the technology is going and what is the effect of that in the world, rather than I was right 2 years ago, 3 years ago. And I believe, faculties, universities have such an important role to play to create a ground where good discussions can happen.
Thank you. Very thoughtful. So I want to actually have a quick follow-up question about your view of sort of open versus closed, because you've done the red teaming, and you saw sometimes these models can do some things that are not good or could be even dangerous. But we heard from the academics that they want to have open models and they want to have compute so they can do research. So practically, what can we do? So on the other hand, we're saying these models are dangerous. They should not be open because people may do bad things with them. But if we close them, then our academics are not able to train students, do further research, validate other things. So practically, what's the solution?
If I knew the solution, we would have implemented it already. But I think that is one of the discussions that need to happen. I can tell you that the work that goes into making a model somewhat safe to release takes longer than the time it takes to build the model itself. For example, for the GPT-4 releases, it took 8 months to build some protections over it so that it could be released into the world. And I think we have to find ways of standardize those techniques as much as possible so that anybody releasing those models into the world can go through those stages not in 8 months, but in the matter of days. And some of those practices can be applied across the board to every model that's going out into the world. There's also a legal question about licenses and how to track, and traceability is a big issue. But again, that's part of the convening, right? Like, you're right, industries have different incentives. But at the same time, we have to come to an agreement that we can all do the work we want to do with open models, but do it in a responsible and safe way.
And do you think it's even possible to guarantee safety for something that's of a level of complexity that we don't even know how it really works? Is it even possible to guarantee safety for something like that?
There are no guarantees right now. Let's admit it. And maybe one day we are going to get there, and that's going to be a breakthrough if we get there. At the same time, we are learning across organizations every day about why it's failing and what is a kind of a closed gap solution we can implement today. We have no way right now sharing that know-how with each other. That's a problem too. Every organization is discovering weaknesses and then patching it, and then the next organization need to find it their own way and their own way and their own way. We are not going to make a lot of progress by kind of decoupling all of this work, because at the same, everybody, Google, Microsoft, there's actually a lot of common goals in all of this. We just don't have the platforms to do that kind of work right now. And again, universities can be a platform to do that kind of work.
Yeah, one thing I'll add is, the safety question is a good one, and I haven't been able to read Red Team, but the challenge in general is that, even if you red team these things, you still don't know what the guardrails, it's hard to know what the guardrails are. So I think this is another opportunity where the university plays a big role as well, is, I was talking about kind of the breadth of knowledge, that we can never replicate it at Microsoft or Google, which you were talking about, where those domains are the ones that are going to allow us to create those smaller models that are actually going to be the practical things. At the end of the day, academia is going to invent the next phase of what's the interesting thing come out of AI. I don't think it's going to be a big tech company. The platform's out there, but I think the application domains are going to be the ones that really kind of moves the needle. But at the same time, I think the breadth of knowledge and expertise can also be brought to bear to think about what are the guardrails we need to think about. Because sometimes in industry, we're thinking about maybe this myopic area of, it might be a Copilot, or it might be this thing that's augmented with Google Search. We have a very specific way we're looking at, but we're not looking at all these other things that could be a guardrail that we need to think about, that it's just something that is not top of mind. And I think that's where the seamless collaboration with the university goes a long way. So.
Just wanted to add something to that. We've talked about the bad outcomes. There is some confusion on the good outcomes side in industry also, which is, what is the measure of goodness? And so let's say I have an ensemble of models, and they're all, it's almost like having 3 kids, and they do differently. I mean, one does good in math, one does good in English. I don't know. I mean, that's where it starts coming closer to an intelligence. My kids don't always get perfect grades, and they don't like all the same subjects. So in that sense, it is becoming a little bit more like closer to human intelligence. And we are expecting each model to be perfect on every scenario. It's not going to happen. So what is a measure of goodness? And, I'm fine that my older son loves math and younger one does language arts, and that's okay. What is a measure of goodness? And what is good enough?
A question from the audience, so I might want to do that actually, and then I have a follow-up, please.
Maybe this is too open-ended to dive into right now, but one thread that I've heard throughout the day that came up just now as well is I'll label as epistemology, right? And I see that there's something, I feel that there's something different going on with the current conversation than really ever has before with software. So it used to be that, you have some system and you sort of package up a set of unit tests and system tests, and you sort of say, hey, it looks like it does this, these are the capabilities, and some customer says, oh, okay, this looks like it roughly matches my requirements, and so I'll deploy it and I can work with it. And here we're sort of trying the same thing, but I don't think it holds, right? You sort of say, well, here's a bunch of tests, here's a bunch of benchmarks, and it looks like it right. And at no point did we actually show that what you are going to do with it in practice, actually, we don't have any, I claim we don't have any good way of reasoning about the connection between my requirements in practice and your sort of fairly random set of benchmarks that you're using to sort of do it. So I guess maybe to frame it as a question, what kind of packages of evidence do you all sort of need to put together, from your point of view, do you need to put together to sell a customer on it? And then back on the university side, what kind of packages of evidence should researchers be thinking about in order to kind of, I heard translation, I heard sort of applications quite a lot and so forth, but embedded in that is some kind of an evidentiary argument about, look, this works and generalizes to other applications. And so I apologize for the very muddy question, but this is something that goes pretty deep here a little bit. I think we're doing it wrong right
I'll
now,
get us
and I don't know how to
started
fix
because
it.
I've been thinking a lot about this. If the objective is inference and reasoning, then unit testing and system testing as if it was a tool or an application or a computer product fundamentally does not reach far enough. So your point about epistemology is absolutely right. That's how I have been wondering about it, which is if I had 3 models and these 3 were my 3 kids, what is the power of inference and power of reasoning within each one of them, and what does goodness look like? And do I actually expect them to say the same answer? Is that goodness of intelligence? Because then I'm saying it should be identical. And that's not going to be of value. So if you have multiple ways of getting to inference or reasoning, then we need a little bit more nuanced way of measuring goodness. I don't think we are there yet, to be honest. We are thinking of it as a computer product. We are testing it like a computer product. We're not giving it the status of an intelligence, a beginning of an intelligence, very fragile 3-year-old toddler, and then taking it on that journey of inference and reasoning.
Yeah, the one thing I would add is we're using classical tools on something that's moving daily, right? I get yet another email from my students saying, oh, look at this new model I built, and look at this new model I built. And so the way that the innovation and the research is happening is also completely different, right? We go from a hypothesis-driven type, set of research programs, then you go to more of a iterative, less waterfall kind of type of mentality. Now it's a very, very different type of approach that you take for research. And so I think just the way we're doing research, also we need to start to take a little bit of a step back to see, is there something more fundamental that we need to adapt to? And I think that's the other thing, kind of going back to the university and industry relationships. Industry is moving very fast to see what's even out there, right? I think that's one of the things where Microsoft and Google the goal here is to look at what's possible and what can we do. But at the same time, the university has its own pace. And I think if that pace doesn't start to catch up in some way, maybe it's through pedagogy, maybe it's through education, maybe it's the way we do research, the way we do collaboration, I think the university will always be at a disadvantage a little bit too. And so, the fact that it takes so much time to revamp a curriculum is a non-starter in the AI space, right? And so I think that's the other thing is how do we educate our students to actually take on a different approach to how they approach research. I think is going to be critical because we're using very classical methods right now.
So that's interesting because I kind of see now 2 sort of differing opinions between Shwetak and Ece, because Shwetak is saying industry is going fast and we need to adapt university so it can also be agile and move quickly. And what Ece was saying is that industry is moving fast because there's commercial pressure to you got to do and go as fast as possible, which doesn't really allow people to step back and sometimes think deeply about problems, and that's the value out of the university to not be under commercial pressure and then step back and see if you should think about problems in a fundamentally different way. So would you like to defend your positions or you want to converge?
I personally don't think we are in a conflict. Let me try to make maybe the connection between the two. Any students that we are educating right now need to know what is happening today to figure out what comes next. In fact, this is a discussion I have with some of the researchers that is like, this transformer thing is stupid. We don't have to build experiments on this. This is where the world's infrastructure is built on. Whatever next idea that comes on is going to be using a similar idea, but moving it forward. So you cannot get there without practicing today's technology. And this is a challenge that our students need to be familiar with what is really going on today. And how do you actually build that curriculum when that underlying technology is changing so fast? At the same time, yes, we need people being familiar with today's technology and then thinking what comes later. Those things have to happen together, which is a challenge because we have to kind of follow the pace, but at the same time, look into the future, and that's a hard thing. I
actually vehemently agree with you, which is, but one thing is that, we definitely have to look ahead. My worry right now is that we're not even keeping pace to even look ahead. So, yeah.
And then I had two quick things to add to Bill's question. One is, we are really building a completely new compute framework at the moment. The compute infrastructure is changing. We don't know what that looks like, but it's not the traditional compute infrastructure. So at the end of the day, this is not going to be you have one language model and you are prompting to it and you are getting a response and giving that to the user, and that's kind of the end of the compute. Not at all. This is actually, yes, having some version of LLMs, probably a family of them, each specialize at different things at the center of this compute platform, and then building memory, building personalization, building feedback loops, building orchestration, building actually abstract level of intelligence over those LLMs to be able to orchestrate that whole thing at scale. And this is a completely new compute framework that we have to think about right now. And while building this stack, we have to think about how we are going to be evaluating each piece of the stack. And evaluation is where we are the weakest at the moment, because we are trying to get the techniques that existed for traditional ML and try to apply them to the current models and show how much progress we have done. And benchmarks are broken, they are memorized, and they don't even capture what new capabilities are coming out of the models. So I'm really hoping that we are going to see some new thinking on the evaluation front, and without that, we are kind of going blind, and we are kind of investing all of this without having the right lights to show us what is coming on the way.
Thank you. So I want to slightly change the topic, going back to working with university. And for this following question, I would invite you not to necessarily think about UW, but you all are in very prominent large companies. Your companies work with probably a multitude of universities. You've seen it probably firsthand how your companies work with universities. If you sort of think about one example of a collaboration between your company and a university that worked really well, so sort of showcase the situation that this collaboration was great, awesome. I was wondering if you could share one example and kind of say how that came about and what was it about that collaboration that made it really great for you guys. And I don't know if Feja, it's okay to start with you, so kind of going back and forth this way, but please.
I'll give a quick example that actually was before my time at Microsoft Research. It was the summer that Jeff Hinton spent at Microsoft Research. This is before the deep learning revolution. He had some ideas about what the scaling of the neural networks would mean. He didn't have the data or the compute to do that. He came to Microsoft Research for a summer. They had the speech data set, switchboard data set, and they spent the summer applying his techniques on that switchboard data set for audio, and then really showed the performance. Of course, a lot has happened since then. But I think that was a good example of like somebody, some academic, saying that I have spent decades, I really believe in this idea. I'm seeing some sparks if I have the right ingredients that I may get from an industrial organization. Maybe we really finally do that thing. And that's, I think, how some of the ingredients came together in that summer. Or maybe it was longer than a summer.
Yeah, that's a great example. And I think we have university leaders here. It's a good example of making it easy for professors to kind of work with industry, and hopefully industry will also make it easy for professors to do that. And I didn't know this example, so I'm going to steal that and use it later. So thank you. Vishwa, how about Boeing?
Yeah,
An
so
example that
I mean,
you'd like to share?
Thanks. I had rattled off a few examples earlier on, but one that comes to mind is when we were doing some low technology readiness level projects, which is basically closer to the experimental. And we spent a lot of time upfront figuring out where the data comes from, what data is required to test the hypothesis, and so on. So a bunch of upfront work went in so that there was no data-related surprises or who brings what to the table. And then initially the PIs from both sides were co-located, and this was pre-COVID, so virtual was not that easy.
Sorry, which university was this?
This was with Berkeley.
Berkeley.
Yeah. And then,
definitely
the
not as
results
good
were
of a
better.
public school as UW. I mean, it's just like,
Yeah. So, I mean, there are many good examples like that. And I had rattled off a few with University of Washington
No,
as
but
well.
I'm sorry for interrupting you. Please continue.
No,
Yeah.
that's about it. Thanks. Go ahead.
So my example is going to be University of Washington. No, so I think one of the things that's been incredibly valuable is that particularly because we do a lot of the work in AI and health or clinical studies. So when you think about being able to experiment, collect data, validate, there's no way we can do that in the context of an industrial setting. We just don't have the patients, the clinical patients, not the other patients. We also don't have patients because. But anyway, but it's the clinical validation. And so doing cohorting, doing clinical recruiting, having a diverse population that you can pull from the indigenous population, rural population, this is really tough. And this is where a top-tier university is really critical to work with because that's how we're going to validate a lot of these things. But what things that's been interesting, so there's a lot of projects in cardiovascular health, pulmonary health. I can go into lots of details there. But the other thing that's been really interesting is that it's not easy to just take Google infrastructure and bring it to the University of Washington and do a clinical study. It's just, there's a lot of reasons for that. There's just the tooling that's just specific to Google that we just can't make public. There's security challenges, there's a bunch of things there. But the thing that's been really interesting as a side effect of this is when working with partners in the Allen School, where we've actually been able to create similar infrastructure that mimics mimics what we're trying to do at Google and still do the clinical study, but then being able to open source those models or that infrastructure so that the academic community can benefit from it and then Google also benefits from it. So the ability to have a strong medical school and an institute that has strength in computing and AI is really critical because now you can start to replicate some of that infrastructure and then that can actually play a role in the academic setting. So those are some of the most compelling collaborations, which is we're not just doing clinical trials here, we're actually building reusable infrastructure that the academic community is now benefiting from, and that's win-win between what Google and what the university is doing.
So, Cecilia, please.
Yeah, so I think one of the challenges, working in medicine, and then really understanding the gap between the domain experts and domain knowledge and the data scientists, right? And because they often don't talk to each other. So one, I would love to know how do we start the conversations, or what is the platform for that? Or because I can tell you, if I email Google tomorrow, they're not going to answer me. So, what are the platforms that could be really beneficial and they're really encouraging those type of conversations?
Yeah. At least one person you can email that'll answer you. That's a great question. I think that we struggle with that all the time. And I think there's a couple of reasons for that. One is where the data resides, right? If the data resides in the Google land versus if it's an open source data set. So a lot of times what we've done in this space is that work with data scientists and academia on open source data sets that are already out there, maybe Mimic or things that might be from the NHS as a starting point to show that initial promise. And then what we've been doing at Google is these kind of joint collaborations where we've got the AI residency program, these kinds of things where you can have a foot in both a little bit so you can benefit from the tools but yet bring your clinical or data science expertise in. So that's something that I'm personally excited to do more of, these kind of concurrent engagements there.
Yeah, and then I'm hoping that there will be that type of collaborations more in the future, because I think that with the advent of this big data and multimodal data like fitness tracking, all this environmental data, I think medicine in general, there's a little bit of blurriness between health and medicine. So we're no longer focusing on diseases. We're leveraging all this multimodal data set to get novel insights, and then finding ways to prevent diseases. So we become healthier, and then the focus becomes on health and not just the medicine.
Yeah, that's right.
Thank you. I have a question for you, for our panelists, about awareness. So you all work with universities, and at least that's my experience is that these collaborations happen typically when you know someone at the university, that person has the right expertise, and you work together, and hopefully that's a fruitful collaboration. But it's really a sort of person knowing person kind of thing, rather than systematically the company and people in the company being aware of what's happening in an institution the size of UW. There's thousands of researchers here. They do all sorts of interesting things. You don't have time to read thousands of papers that come out of here. So do you have any suggestions of what kind of mechanisms a university can put in place or the company can put in place so you're aware of what's happening here? So these collaborations can happen in a more systematic way. You can find the right person at UW that's relevant to what you would like to do. Any suggestions?
Yeah, a couple quick things. I mean, I agree. I think it's really, if you know, if a PI knows a researcher at one of these companies, it's the strongest. That's historically how a lot of this has worked. But being on the other side at Google, I'm often shocked on, you know, even my team that's in Seattle, in Fremont, mile and a half down the road. It's like, oh, I didn't know we were doing that in the Allen School. It's like, how can that even be a thing, right? And part of it is because a lot of the work that they're doing is very focused in a particular area where if they're not quite looking just on the fringes or maybe just something that's a little bit orthogonal from it. And I think opportunities to just make it easier for creating either workshops or get-togethers, I think is going to be, is critical. Because we did a little bit of this with computing for the environment. Just that one little meetup enabled a set of collaborations that that wouldn't even have happened because those folks weren't talking, because those connections weren't there. So we need to create ways that those are a lot more frequent and I think frequency is a big thing there. But I was very surprised that just a lot of, at least some of the researchers in industry are not looking that broadly, except for the ones that are active in the academic community or have, you know, affiliate faculty positions or are publishing in those conferences, right? It's the researchers that are more on the translational side or more research engineers who would benefit from these collaborations, just don't have the visibility.
Yep.
Yeah.
You know, there's no way to replace the human connection. And we have to find ways of bringing the human connection back. I feel like before COVID, there was just more happening face-to-face. MSR had a bunch of programs with UW. I don't think they are happening anymore. So from my perspective, especially talking about MSR, we have to bring those programs back and think about how to scale them as fast as possible. We are going to benefit as much as hopefully UW will benefit from it.
Vishwa, would you like to add anything, or any mode of collaboration that you found that would allow Boeing engineers to know what's happening at UW and UW professors knowing what's happening?
Yeah,
at
so we have a
Boeing,
very active office, and Scott was here. Scott and Michelle do a really great job of communicating back into Boeing. We also have a fairly long history of people knowing each other, so that just continues the engine.
All right, thank you. Wow, question over there.
So I like the question, is how can a university make itself available to tell a company that does not know what's going on in a university, all the faculty, all the research. So I'm going to talk about one of the mechanisms we have at UW, self-serving. Shatak, you know that. You worked with us on PHI when we applied for one of the NSF grants. So one of the front, not the only, one of the front pushes here at the university is the Population Health Initiative, where if you come to us, and then we'll work with Mary and Jan is here, I can go to Frank and say, if you need business, and I can find out that research in business. I can go to Hillary and find the research in school public. And we created a library in Population Health Initiative of what research is going on. So we know these people. We've been funding them to do these grand challenges, these innovations. So we have a front porch at the, not the only one. I don't want to get in trouble here. We have a front porch that can allow you, if you come to us, we can navigate within this complex and very, very sophisticated system here, and we could help you to make this connection. I'm very much interested in students. And we have been talking with the president and the leadership at this university, how can I get the students involved early on? And how we can create a mechanism, not only when somebody graduates from business, we have a warranty on them, system of warranty for 1 year or 2 years. If they get into a project with one of your company, the professor who graduated them will help you as well. So we create that system internally. So happy to talk about this. PHI, Population Health Initiative, is one of the mechanisms.
So the student warranty is that if the student is not good, you're going to take him back at the university, like fire him from Google? Or like,
We are University of Washington. We don't graduate bad students.
Yeah, just checking. Okay, so Francois is here. I think we're at time. Are there any sort of last questions, pressing questions? We should wrap up, I think.
Some concluding,
I think I've said everything. I mean, I like, I'm a little biased, but I'm an advocate of strong industry-academia collaboration, especially fluidity between students and faculty.
In all new areas, as well as, previously mature areas, I think there is a lot of opportunity for us to work together, look at the breadth of how these disciplines come together, and I think universities can do that really well.
Thanks for inviting me. This was a great conversation. I would really love to figure out how to create some mechanisms to talk more between the organizations. Maybe there is one or two sync-ups that we can schedule right away. I would really like to move, not only leave it at this discussion, but take some steps as well to make it happen.
Thank you. I'm really grateful that you took the time. So I know that you all have day jobs, so you took a lot of your time to be here and share your wisdom. It was a very good panel. Thank you very much. Thank you.